Ancient stones are beginning to speak their secrets. A revolution in scanning technology is unlocking engineering marvels lost for thousands of years, revealing a past far more brilliant than we ever knew. By the end of this journey, you will see 25 astonishing discoveries that are fundamentally rewriting our understanding of human history. We will see hidden chambers inside the Great Pyramid, rivers of liquid metal beneath a temple, and entire cities revealed beneath jungle canopies. These are not just artifacts, they are testaments to a genius we are only beginning to comprehend. How much of our own story have we gotten completely wrong? For 4,500 years, its silhouette against the desert sky has been the very definition of mystery. The Great Pyramid of Giza stands as a monument of perfect geometry, a colossal puzzle box carved from 2.3 million blocks of stone. Generations of explorers, from ancient treasure seekers to modern archaeologists, have mapped its known passages, the descending corridors, the Queen's Chamber, and the soaring Grand Gallery leading to the King's Chamber. We thought we knew its layout. We were wrong. The first secret revealed by our new technological eyes is that the pyramid holds emptiness where we believed there was only solid rock. Using a method called Muon tomography, scientists have essentially given the pyramid an X-ray, but instead of using standard rays, they use particles called muons that rain down from space every moment of every day. These cosmic particles pass through solid matter, but they are absorbed or deflected at different rates depending on the density of the material. By placing sensitive detectors inside the known chambers, researchers from the International Scan Pyramids project could map where muons pass through easily, revealing hollow spaces. And what they found was astonishing. Deep within the pyramid's heart, above the Grand Gallery, lies a cavernous emptiness now called the Big Void. This is not a small crack or a builder's oversight. It is a deliberate space nearly 100 feet long, with a cross-section similar to the Grand Gallery itself, sitting there in perfect silence for millennia. Another, smaller void was detected behind the pyramid's north face. These are not tombs, they are not filled with treasure, at least not in the conventional sense. Their treasure is the question they pose. Why are they there? One leading theory is that they are structural relief chambers, ingeniously designed by the ancient engineers to redistribute the immense weight of the stone above and prevent the Grand Gallery from collapsing under thousands of tons of pressure. It is a breathtaking display of architectural foresight. Another, more tantalizing idea is that these voids served a ritual or symbolic purpose, perhaps representing a pathway for the spirit in the afterlife, a hidden component of the pyramid's sacred function that we simply could not perceive until now. This discovery fundamentally challenges the narrative. It tells us that even our most studied, most iconic ancient wonder still has entire chapters of its blueprint missing from our understanding. If something as massive as a 100-foot chamber can hide in plain sight for 45 centuries, what else have we missed? The answer, it seems, is not just above us in soaring monuments, but deep below our feet. That hidden architecture beneath the stone is mirrored by a hidden element beneath the earth, one that flows with a strange and dangerous life of its own. Far from the Egyptian desert, in the highlands of central Mexico, lies the vast ceremonial complex of Teotihuacan. For centuries, its silent pyramids and broad avenue of the dead have whispered of a powerful, mysterious civilization that vanished long before the Aztecs arrived, naming it the place where gods were born. We knew it was a city of profound spiritual significance, but what lay beneath its central temple was a secret of both dazzling artistry and startling science. Beneath the pyramid of the feathered serpent, using non-invasive electrical resistivity scanners that map the density of materials underground, archaeologists made a discovery that seemed to belong more to myth than to archaeology. They found significant quantities of liquid mercury. This was not a trace element or a spill from a small container. The scans suggested pools of it, perhaps even channels, representing a considerable volume of this rare, toxic, and mesmerizing metal. To understand the scale of this, consider the process. Mercury, or quicksilver, is a metal that is liquid at room temperature, shimmering with a mirror-like surface. It is found in nature primarily as a red ore called cinnabar. The ancient builders of Teotihuacan would have had to mine this ore from distant sources, transport it back to the city, and then master the dangerous process of heating it to release the pure, liquid metal. This alone speaks to an advanced knowledge of pyrotechnology and material handling. But why go to such extraordinary and hazardous lengths? The answer lies in the symbolic landscape of the ancient world. For many Mesoamerican cultures, Mercury, with its uncanny, fluid reflectiveness, was considered a sacred substance. It was associated with water, but also with mirrors that could act as portals to other realms. Researchers now believe these subterranean mercury pools were a deliberate, engineered representation of an underworld river. Imagine a priest or a ruler descending into a chamber beneath the pyramid, their torchlight catching the shimmering, silvery surface of a slow-moving metallic river. It would have been a stunning sensory experience, a physical manifestation of a cosmological belief, transforming the very ground beneath the temple into a symbolic landscape of the afterlife. This finding forces us to radically reassess the technological capability and the spiritual ambition of Teotihuacan's builders. They were not just stacking stones, they were engineering sacred geography, using one of the most difficult materials on Earth to make the mythic tangible. It reveals a society that blended profound ritual purpose with sophisticated material science, daring to harness a dangerous element to bridge their world with the world of the gods. If they could command rivers of liquid metal, what other secrets of their world remain pooled in darkness, waiting for our scanners to find them? The shimmering mercury rivers of Teotihuacan show a civilization shaping the underworld, but another ancient society performed an even greater act of engineering, one that shaped the sky itself. In the stark, rose-red cliffs of southern Jordan, the city of Petra has long been celebrated for its breathtaking tombs carved directly into the rock face. For generations, visitors have marveled at the treasury and the monastery, seeing a city of the dead. But cutting-edge terrestrial laser scanning and sophisticated hydrological modeling are now telling a completely different story. They reveal that Petra's true genius was not in commemorating the departed, but in sustaining the living. The scans have meticulously mapped an invisible web beneath and around the stone city, a vast, intricate network of water management so advanced it feels modern. The Nabateans, the people who built Petra, transformed a punishing desert canyon into a lush, thriving metropolis supporting tens of thousands, and they did it by mastering every drop of water. This was not a simple system of a few wells. It was a metropolitan-scale utility, engineered with astonishing precision. Using laser scanners that can detect the subtlest contours on cliff faces and across wadis, researchers have charted an extensive grid of dams, channels, cisterns, and ceramic pipelines. They built massive dams to divert the destructive force of seasonal flash floods, not just away from the city, but into a carefully designed collection system. From there, a network of narrow, carved channels and underground pipes, laid with precise, calculated gradients, carried water silently across miles of terrain. They even incorporated settling tanks and filtration systems using sand and gravel to purify the water before it reached their reservoirs and homes. The entire city was plumbed. This level of hydrological engineering in the middle of the 1st century is staggering. It speaks of a deep, scientific understanding of their environment, of rainfall patterns, water flow, and storage principles. They did not just adapt to the desert, they rewrote its rules, creating an artificial oasis through sheer innovation. So what does this 2,000-year-old plumbing manual teach us today? In an era where many regions face increasing water scarcity, the Nabatean model is a masterclass in sustainable, passive technology. They achieved a perfect balance of collection, conservation, and distribution without a single electric pump. Their system was resilient, built to last for centuries, and seamlessly integrated into the natural landscape. It reminds us that some of the most powerful solutions are not about overpowering nature, but about understanding its rhythms and designing with elegant efficiency. Petra was not a tomb city surviving in a desert. It was a hydraulic empire thriving because of it. This revelation shifts our gaze from the grand facades meant for the afterlife to the brilliant, practical infrastructure that made daily life possible. And as our scanning technology peels back these layers of practical genius, it begins to uncover an even more profound layer of ancient thought, one that connected their earthly creations directly to the heavens above. The silent stones of Stonehenge have always been a question etched against the English sky. For generations, we saw them as an isolated circle, a mysterious temple standing alone on the open plain. But our new vision, provided by ground-penetrating radar that sees deep into the earth without disturbing a single blade of grass, has shattered that lonely image. The scans reveal that Stonehenge was never alone. It was the brilliant central jewel in a vast engineered landscape of staggering scale. Surrounding the nearby Durrington Walls Henge, a site associated with the builders of Stonehenge, researchers discovered a pattern of at least 20 massive pits, each over 30 feet across and 15 feet deep, forming a great circle nearly 1.5 miles in diameter. This circuit, over 4.5 kilometers around, encloses an area greater than 300 football fields. Some of these pits appear to have held enormous timber posts or perhaps even standing stones that were later removed or buried, a ghostly outline of a monument that once was. This discovery redefines the site entirely. We are no longer looking at a single stone circle, but at a superhenge, a colossal ritual complex meticulously planned and executed across an immense geography. The sheer labor involved is almost incomprehensible. To excavate these giant pits with antler picks and stone tools, to possibly transport and erect monoliths within them, speaks of a society with extraordinary organizational power. It suggests a level of social cohesion, shared purpose, and engineering logistics that we rarely attribute to Neolithic farmers. They were not just building a monument, they were sculpting the very land itself on a heroic scale, turning miles of countryside into a sacred precinct. This forces us to ask with new urgency what profound ceremony or belief demanded such an immense stage. The answer likely lies not just in the earth but in the sky above it. To align their world with such precision, these ancient engineers must have been master astronomers, using the landscape itself as a celestial calculator. From that monumental landscape of earth and sky, our search for hidden knowledge now plunges beneath the waves. In the quiet depths off the coast of a Greek island, a shipwreck from the 1st century before the Common Era held a secret that would take over 2,000 years to fully comprehend. When divers first recovered a lump of corroded bronze and wood from the Antikythera wreck in 1901, it was catalogued as an unremarkable piece of nautical debris. Decades later, someone noticed a gear wheel embedded in the rock like corrosion. That single observation began a century-long detective story, one that would culminate with a technological revelation so profound it forced us to rewrite the history of human invention. The object, now known as the Antikythera mechanism, is the world's first known analog computer. But to truly understand its genius, scientists needed to see inside without destroying it. They turned to a process called microfocus X-ray computed tomography, a form of three-dimensional X-ray imaging so precise it can map the internal structure of an object in microscopic detail. Peering through the layers of calcified sea crust, the scans revealed not just one or two gears, but an intricate, miniaturized cosmos of bronze machinery. The device contained a complex system of over 30 precisely meshing gear wheels, some with teeth so fine they were barely a millimeter thick. These were not crude castings, they were works of exquisite precision engineering, arranged on multiple axles within a wooden frame about the size of a shoebox. By turning a hand crank on the side, the entire system would whir into motion, its dials and pointers moving in synchronized harmony to calculate celestial events. This was not a simple calendar. The mechanism could predict the positions of the sun and moon, the phases of the lunar cycle, and even the timing of solar and lunar eclipses years in advance. One dial tracked the 4-year cycle of the ancient Olympic Games. Another likely showed the wandering paths of the 5 known planets. Perhaps most astonishingly, it employed a differential gear, a complex arrangement that calculates the difference between 2 rotational inputs to produce a third output. This same principle is at the heart of every modern automobile's axle, yet here it was, engineered in bronze 2,100 years ago. The existence of this device shatters the conventional timeline of technological progress. It tells us that in the workshops of ancient Greece, a level of mechanical sophistication flourished that we simply did not believe was possible for that era. This was not a lucky prototype, it was a refined instrument implying a tradition of geared technology, a school of thought and craftsmanship that has been completely lost to history. The mechanism forces a humbling question: what other leaps of engineering and science from the ancient world have vanished without a trace, their secrets still resting in undiscovered shipwrecks or buried in the foundations of forgotten cities? The Antikythera mechanism is a single, surviving whisper from a conversation about the universe that we thought began much, much later. The silent gears of the Antikythera mechanism charted a cosmos of bronze and mathematics, but that same Mediterranean Sea which preserved it also swallowed another marvel of ancient engineering. Off the coast of modern Israel, the waves now hide what was once the pinnacle of Roman ambition, a harbor so advanced its secrets were only fully understood when we could scan the seafloor. This is Caesarea Maritima, and beneath the silt and sand, underwater LiDAR and sonar mapping have exposed not ruins, but a perfectly preserved blueprint of imperial power. The scans reveal a harbor engineered not just for trade but for dominance. The Romans faced a fundamental problem here. The coastline offered no natural shelter for ships. Their solution was to build a harbor from scratch, directly into the open sea, a task requiring a material that defied the ocean itself. That material was a revolutionary hydraulic concrete. While we use similar principles today, the Roman formula, revealed by scans of the massive submerged blocks, was a masterpiece of materials science. It incorporated volcanic ash from Italy, which, when mixed with lime and seawater, triggered a chemical reaction that allowed the mortar to cure and harden underwater, actually growing stronger as it was pounded by the waves. But the innovation did not stop at the recipe. The sonar imagery shows the construction technique in stunning detail. To form the colossal breakwaters, Roman engineers built enormous wooden forms, essentially hollow boxes, floated them into position, and then filled them directly in the water with this miraculous concrete. The result was artificial peninsulas of stone that created a calm, deep waterport where none existed before. Within this protected basin, the scans outline a complex, efficient machine of commerce. Vaulted warehouses for grain and goods lined the docks, with loading cranes and a sophisticated system of channels to guide ships to their berths. This was not a simple dock, it was a metropolitan transit hub, the ancient equivalent of a superport, enabling Rome to control the flow of wealth across the entire Mediterranean. This discovery forces two profound questions. First, how did such a specialized technology, requiring specific volcanic ingredients shipped across the sea, spread throughout the empire? It speaks to a highly organized, centralized knowledge network where engineering protocols and material recipes were treated as state secrets, disseminated to build the infrastructure of control. And second, why was this knowledge lost for centuries after the empire's decline? The answer lies in the collapse of the complex systems that sustained it, the trade routes that brought the special ash, the centralized authority that funded such monumental projects, and the specialized guilds of engineers who guarded the craft. When that intricate societal machine broke down, the formula for the concrete that conquered the sea simply faded from memory, buried as surely as the harbor itself. It is a stark lesson in how fragile advanced knowledge can be, reliant not just on genius, but on a civilization stable enough to maintain it. From this sunken monument to material science, we now turn to an ancient structure that seems to defy a different, more fundamental force, the very pull of gravity itself. Gravity seems to lose its meaning at the fortress of Sacsayhuamán. The walls here are a symphony in stone, a zigzagging series of colossal blocks, some weighing more than 100 tons, stacked into ramparts that dominate the hills above Cusco. To the naked eye, the fit between these giant stones is breathtaking, with seams so tight you cannot slip a piece of paper between them. But three-dimensional laser scanning has done more than just confirm this perfection. It has quantified it with a precision that stuns modern engineers. The scans map every microscopic contour, revealing that over vast multi-ton surfaces, the mating faces of these stones are ground to a tolerance of less than a single millimeter. This is not simply close fitting. This is machining level accuracy achieved on an architectural scale, all without iron tools, without mortar, and without the wheel. How was such impossible precision possible? The laser models provide a clue, showing that the joints are not simple flat planes. Each stone is a unique, three-dimensional puzzle piece, with faces that curve subtly inward, creating complex interlocking shapes. This was a deliberate, brilliant engineering solution. In a region plagued by massive earthquakes, these walls were designed to dance. When the ground shakes, a rigid structure will crack and collapse. But the intricate, jigsaw-like fit of Sacsayhuamán stones allows them to shift and settle during a tremor, then lock seamlessly back into place as the energy passes. They are not just walls, they are seismic dampeners carved from solid rock. This revelation transforms our understanding of Inca capability. This was not an achievement of brute force, but of a highly refined, systematic stonemasonry technique. It implies a profound knowledge of geometry, material behavior, and a measuring system precise enough to transfer complex templates from the architect's plan to the quarry, and then to the final fitting. The tools they used, likely harder stones, sand, and water for polishing, were simple. The knowledge behind their application was anything but. Even with our diamond-tipped saws and computer-guided cutters, replicating this feat on such a scale would be a monumental challenge. It forces a humbling question. Did the Inca possess a lost school of practical geometry, a way of seeing and shaping the world that we have yet to fully comprehend? Their pursuit of perfect, enduring order in stone seems to reflect a deeper desire, one to align their entire world with a grander, celestial pattern. The pursuit of perfect order in stone leads us to a civilization that mastered a far more fluid element. For centuries, the temples of Angkor Wat rose from the Cambodian jungle like beautiful, isolated islands in a sea of green. We saw them as magnificent spiritual centers, but we could not see the world that sustained them. The jungle canopy was too dense, the ground too obscured. That is, until a revolutionary eye in the sky looked down and saw through it all. Using a technology called airborne LiDAR, which fires millions of laser pulses from an aircraft to map the ground surface beneath the vegetation, researchers performed a kind of digital deforestation. In an instant, they stripped away 1,000 years of overgrowth, and what appeared was not just a few more temples, but an entire civilization laid bare. The scans revealed a sprawling, low-density urban metropolis of staggering proportions. This was not a dense cluster of buildings, but a vast, engineered landscape. The LiDAR maps show an extensive, orderly grid of raised earthen roads, intricate networks of canals, thousands of household mounds where families lived, and countless community ponds. This meticulously planned infrastructure proves that Angkor was not merely a ceremonial site. It was one of the largest pre-industrial cities in the world, a continuous urban area that may have supported close to 1 million people at its height. The sheer scale of its planning is breathtaking, but the true genius of Angkor, revealed in stunning clarity by the scans, was its relationship with water. The city was built upon a sophisticated, metropolitan-scale water management network. At its heart were the massive artificial reservoirs called barrays, which were not just symbolic pools but functioning engineering projects of staggering ambition. The largest, the West Barray, is an artificial lake 5 miles long and 1.5 miles wide, containing over 50 million cubic meters of water. Canals, meticulously aligned, distributed this water across the urban grid and into the surrounding rice fields. This system was far more than just irrigation. It was a tool for climate control and flood mitigation, a way to harness the monsoon's abundance and survive its dry seasons. This discovery fundamentally transforms our understanding. Angkor was not a collection of temples in a jungle. It was a meticulously planned hydraulic city, a machine for living built by engineers who shaped water with the same reverence and skill as they shaped stone. It forces two profound questions. How did such a vast population sustain itself in this environment? The answer lies in that engineered landscape, a testament to a society that achieved a fragile, brilliant balance with nature. And what caused its eventual decline? Research suggests that shifts in climate, combined with the immense strain of maintaining such a complex water network against siltation and changing rainfall patterns, may have gradually tipped that balance. The city's greatest strength, its mastery of water, may have also contained the seeds of its vulnerability. This revelation shows us that the grandeur of ancient civilizations was often built upon foundations of practical, everyday genius, systems that fed millions and shaped empires. And as our scanning gaze moves from these vast networks of life, it now turns to more intimate spaces, to the final resting places of rulers, where guardians of stone have kept their silent watch for millennia. Buried in silent ranks for over 2,000 years, the terracotta warriors were always more than just an army of clay. We saw their numbers, their weapons, their imposing presence guarding the tomb of China's first emperor. But to truly understand the miracle of their creation, we had to look closer, much closer, at the face of a single soldier. Advanced three-dimensional scanning has done just that, mapping the contours of thousands of individual faces, hairstyles, and suits of armor with microscopic precision. The data confirmed a stunning truth: no two faces are exactly alike. This was not an illusion of artistic flair. It was the result of a manufacturing system of breathtaking sophistication. The warriors were not mass-produced from a handful of molds. Instead, they were built using a modular assembly line process that rivals modern industrial methods. Think of a vast workshop, a factory of immortality. In one section, artisans crafted legs from standardized molds. In another, torsos were formed. Arms, hands, and heads were produced in separate batches. These components were then brought together and assembled, the joints sealed with clay. But here is where the system transcended mere production. Once the basic soldier was pieced together, master artisans added the individualized features by hand. Using tools to imprint, carve, and shape the soft clay, they created unique eyebrows, mouths, cheekbones, and hairstyles. transforming a standardized component into a distinct individual. Some scans even reveal fingerprints pressed into the clay, the literal touch of an ancient artist immortalized beside an emperor. This reveals a project of staggering logistical and artistic engineering. The scale is almost incomprehensible, an estimated 8,000 soldiers along with hundreds of chariots and horses, each one a product of this coordinated system. It speaks of a society with an unprecedented capacity for organization, specialization, and quality control. The Qin dynasty did not just conquer and unify China through military might. They administered it with a bureaucratic precision that extended even to the afterlife. This army was a physical manifestation of that control, a permanent garrison assembled through the same principles of standardized parts and centralized command that built an empire. It forces us to ask, what does this manufacturing system reveal about the world above the tomb? It tells us of a society capable of mobilizing and managing thousands of skilled craftsmen, of maintaining supply chains for materials, and of enforcing a singular, monumental vision with relentless efficiency. The emperor's desire for a personalized eternal army was not just vanity, it was the ultimate expression of a new kind of power, one that could shape not only the living world, but the realm of eternity itself, one meticulously crafted face at a time. And from this silent, sculpted army, we now perceive another kind of shaping, one not of clay, but of sound itself, where ancient builders engineered not what we see, but what we hear. Deep within the stone heart of the Andes, a different kind of engineering whispers through the dark. The temple complex of Chavín de Huántar is a maze of underground galleries and narrow ducts, a place where architecture was designed not just for the eye, but for the ear. Modern acoustic scanning, which maps how sound waves travel and reflect, has decoded this ancient auditory blueprint. Researchers discovered that specific stone conduits and carefully shaped chambers function as a sophisticated sound system. When a priest blew a ceremonial conch shell trumpet known as a pututu, its deep, resonant blast was not merely heard, it was transformed. The sound would travel through these hidden channels, emerging in distant rooms with an eerie, distorted echo. It could make the blast seem to come from multiple directions at once, or even appear to emanate directly from the mouths of the temple's monumental stone sculptures. For a visitor in the flickering torchlight, the effect would have been profoundly disorienting and mystical. The stones themselves seemed to speak, delivering the voice of a god or an ancestor. This was not an accident of construction. It was a deliberate, engineered illusion, a tool of spiritual authority crafted from rock and resonance. It reveals a level of sophistication where the architects considered the complete sensory experience of ritual, using physics to shape belief. This finding prompts a wider question for archaeologists. How many other sacred sites around the world hold similar designed acoustic secrets, where the very walls were tuned to alter human perception? It shows that ancient genius was not only in moving mountains of stone, but in bending the invisible waves of sound to their will. From this orchestration of sacred sound, we now find a civilization that orchestrated something even more vast, aligning its entire world with the silent, eternal motion of the stars. The stonework at Newgrange holds a perfect alignment with the sun, a feat of engineering timed to a single day each year. This massive circular mound in Ireland, older than both Stonehenge and the pyramids, is famous for its winter solstice phenomenon, where a beam of sunlight pierces a narrow opening above the entrance and travels down a long, dark passage to illuminate the inner chamber. For generations, this was seen as a beautiful, perhaps symbolic alignment, but recent high-resolution laser scans have mapped the structure of that opening, known as the roof box, with unprecedented detail, revealing it to be a precision astronomical instrument carved from stone. The scans show that the large slab forming the roof of the light channel is not simply a flat stone placed overhead. It has been meticulously engineered, its underside carved with a shallow groove and angled with exacting care. This groove acts as a sightline, a built-in targeting system that captures the first golden rays of the solstice sunrise and funnels them into a clean, concentrated beam. The entire apparatus is calibrated for a specific, fleeting window of opportunity, just 17 minutes as the sun crests the horizon. This narrow time frame confirms the builders were not merely marking the general solstice. They were capturing a precise moment of celestial rebirth, year after year, with a reliability that feels almost modern. To achieve this 5,000 years ago required more than observation. It demanded a profound, transferable knowledge. The architects had to understand the solar cycle with enough certainty to design and construct a permanent, immovable structure that would function perfectly for millennia. They had to translate that celestial knowledge into practical stonemasonry, calculating angles and alignments in 3 dimensions, then executing those plans on a monumental scale. This was not a happy accident of architecture. It was a calculated fusion of astronomy, geometry, and engineering. It forces us to reconsider the intellectual landscape of Neolithic Europe. If one site demonstrates such a sophisticated, encoded understanding of the cosmos, what other celestial events, lunar cycles, or planetary alignments might be secretly woven into the standing stones and earthworks scattered across the continent? The quest to read these ancient stone calendars continues, leading us from the green hills of Ireland to a much harsher, drier landscape, where another civilization sought to align its greatest monuments not just with the sun, but with a timeless, unchanging north. The quest for perfect celestial alignment found its counterpoint in a monument that dared to bend. On the edge of the Egyptian desert, the bent pyramid of Dosha rises with a startling, broken silhouette, its smooth sides abruptly changing angle halfway to the sky. For centuries, this kink was seen as a mistake, a sign of ancient architects who miscalculated and had to hastily correct their ambition. But the Muon scans that peered inside the Great Pyramid have also looked into this one, and they tell a story not of failure, but of brilliant, real-time problem-solving. The internal density maps reveal a structure under tremendous internal stress from its own immense weight. The scans suggest that as construction progressed on the original, steeper angle, the builders observed alarming signs, perhaps cracking in the inner chambers or unsettling shifts in the core masonry. Faced with a potential catastrophic collapse, they did not abandon the project. Instead, they executed a mid-construction redesign, reducing the angle of the upper sections to a more stable, gentler slope. This was not a panicked fix, but a calculated engineering intervention. It demonstrates a profound, empirical grasp of structural mechanics. These ancient builders were actively experimenting with the limits of stone and gravity, learning from the feedback of the monument itself. They possessed a form of risk management, an ability to assess a threat and adapt their grand plan to ensure its survival. The bent pyramid is therefore one of history's most honest textbooks. It is not a perfect, finished theory, but a preserved moment of trial, error, and ingenious correction. It showcases a resilience and pragmatism in the face of the physical world that is as impressive as any flawless final product. Their lesson was clear: true mastery lies not in never encountering a problem, but in developing the wisdom to solve it, even if it means changing the shape of your dream. This monumental act of adaptation finds a parallel in objects of breathtaking delicacy, where engineering brilliance was compressed into the space of a human hand. From the colossal to the cryptic, another ancient puzzle is etched across 1,000 square kilometers of Peruvian desert. The Nazca lines are a gallery of giant spiders, hummingbirds, and geometric shapes so vast they only make sense from the sky. For generations, their purpose has sparked theories of alien runways or celestial maps. But the real secret lies not in why they were made, but how. High-resolution drone photogrammetry, which builds a three-dimensional model from thousands of overlapping aerial photos, has finally decoded their construction. The scans show the lines were not carved or dug, but created by a process of subtraction. The desert floor here is covered with a layer of dark, oxidized stones. The ancient artists simply removed these surface stones along the lines of their design, exposing the lighter, sandy soil beneath. This created a stark, high-contrast image that has endured for over 2,000 years. The precision, however, is the true marvel. How do you create a perfectly straight line that runs for kilometers, or a symmetrical hummingbird with a wingspan wider than a jetliner, when you are standing on the ground and cannot see the whole picture? The scanning data provides the answer. The designs were first laid out using a system of simple ropes and stakes, a scaled-up version of the geometric techniques used for smaller plots. The drone models reveal small post holes and stone piles at key points, likely used as anchor markers. By establishing a central axis line and using measured chords to plot curves and angles, teams of workers could execute small, manageable sections of the grand design, one after another, with each segment aligning perfectly with the next. This required an intricate, shared mental blueprint and an extraordinary understanding of perspective and proportion. They were not drawing a picture, they were performing a coordinated, large-scale land survey, translating a master plan across a living landscape without ever seeing the final form. This feat of communal engineering forces a profound question. What does this say about the society that created them? It speaks of a culture capable of immense collective action, of organizing and feeding large groups of people to work on a project with no immediate practical return. The lines were not for irrigation or defense, they were for something beyond the everyday, perhaps a way to communicate with deities in the sky or to mark sacred pathways known only from a higher vantage point. Their genius was in merging simple, accessible tools with a sophisticated, shared vision, proving that monumental art does not require complex technology, but rather an unshakable shared purpose. And as we contemplate these vast drawings made for a view from above, our scanning technology now invites us to look in the opposite direction, to discover entire cities that did not reach for the sky, but instead carved their grandeur deep into the earth below. While the Nazca artists shaped the desert surface, other civilizations sought safety by disappearing beneath it. In the heart of Cappadocia, Turkey, the landscape is a fantasy of soft volcanic rock, sculpted by wind into towers and cones. Here, the true marvel is not what rises from the earth, but what lies hidden within it. Derinkuyu is an entire city carved downward, a labyrinthine refuge extending over 18 levels deep into the stone, capable of sheltering up to 20,000 people along with their livestock and food stores. For decades, we marveled at its sheer scale, the chapels, stables, and wine presses all carved underground. But the most critical question remained: how did so many people breathe and live down there for months, even years, without detection? The answer has been fully revealed only through three-dimensional laser mapping, which has charted every corridor, chamber, and, most importantly, every hidden airway. The scans detail an environmental control system of breathtaking sophistication. The city was sustained by over 50 vertical air shafts, each one a masterpiece of clandestine engineering. These were not simple holes, they were carefully calculated conduits, some plunging over 80 meters straight down from the surface, strategically positioned throughout the complex to create a continuous, passive flow of fresh air. The genius lay in their placement and disguise. The shafts often opened to the surface in remote, hidden locations, perhaps within natural rock formations or concealed crevices, making them virtually invisible to anyone above. Inside, they were carved with subtle, angled bends or connected to communal areas like kitchens, where rising heat from fires would help draw stale air up and out, pulling fresh, cool air down through other shafts in a natural circulation system. This was not just ventilation, it was a life support network, a literal breath of life for a community in hiding. It required a holistic, almost intuitive understanding of airflow dynamics, geology, and human sociology. The builders had to predict how air would move through miles of tunnels, how to prevent deadly carbon dioxide from pooling in lower chambers, and how to do it all without revealing their presence with telltale plumes of smoke or sound. This engineering speaks of a society shaped by profound necessity. What drove people to invest generations in carving out such an elaborate, deep sanctuary? The answer is a long history of seeking refuge from conflict, a need for security so great that the only solution was to vanish entirely from the world above. Derinkuyu is a monument not to conquest but to resilience, a testament to the human instinct to preserve community against all odds, and to the brilliant, practical minds that made long-term survival in the dark not just possible but sustainable. This deep-seated drive to secure a community's future finds a powerful parallel in another ancient endeavor, one that looked beyond the survival of the living to ensure a majestic, engineered passage into the afterlife. The silent terracotta army guards a secret even more astonishing than their own creation. Beneath the great, unopened mound that holds the emperor's chamber, ancient texts speak of a breathtaking wonder, a miniature kingdom complete with rivers and seas made not of water but of shimmering, liquid mercury. For centuries, these accounts were dismissed as myth, the fanciful legends of a ruler's extravagant afterlife. Modern science, however, has given those ancient words a powerful voice. Remote sensing surveys and meticulous soil chemistry tests around the perimeter of the tomb mound have consistently detected unusually high concentrations of mercury vapor rising from the soil. This is not a trace element or background noise. The readings are significantly elevated, forming a distinct chemical signature that maps to the shape of the burial complex itself. The scientific evidence now strongly suggests the ancient historians were recording a literal truth. This confirmation transforms the story from legend into a staggering engineering puzzle. To create a topographical map of China's great rivers with flowing mercury would have required a mastery of both metallurgy and hydraulics on an imperial scale. Engineers would have needed to design and seal vast, intricate channels within the tomb's architecture, calculating slopes and volumes to keep the dense, toxic metal in perpetual, slow motion. This was not a static pool, it was meant to be a dynamic, miniature empire in motion, an eternal dominion for the emperor's spirit to rule. The ambition is almost beyond comprehension. It reflects a belief that the cosmos could be miniaturized and controlled, that the very geography of power could be recreated underground with the most rare and magical substance they knew. This scientific corroboration forces a profound and tantalizing question. If the Mercury rivers are real, what other marvels of art, technology, and organization lie perfectly preserved in the dark, waiting within that untouched mound? The emperor's entire court, his palaces, his treasures, all suspended in time, protected by booby traps and a river of quicksilver. It stands as perhaps the greatest unopened archaeological treasure chest on Earth, a sealed capsule of an empire's zenith. This desire to architecturally capture the order of the cosmos was not unique to China. It was a pursuit that spanned the ancient world, driving builders to align their greatest cities with the very machinery of the heavens. That profound desire to align with cosmic order found its ultimate earthly expression on a mountain ridge in the clouds. Machu Picchu appears to defy gravity, its elegant stone structures clinging to a narrow saddle between two towering peaks. For a century, we admired its beauty and wondered how it remained so perfectly intact. The answer was not in the stones we could see, but in the genius we could not, buried deep beneath our feet. Ground-penetrating radar has now scanned beneath the iconic terraces and plazas, revealing that the city is not built on the mountain, but is an extension of it, a masterclass in foundational engineering. The scans show a deeply layered, intentional construction. The Inca engineers did not simply level the ground and start building. They began by excavating down to the bedrock and then laying a thick, permeable foundation of crushed rock. This layer acts like a giant sponge and a shock absorber, allowing subsurface water to drain away quickly. On top of this, they built their signature retaining walls and then filled the terraces with a carefully sorted gradient of materials, from larger stones at the bottom to finer gravel and rich topsoil at the surface. This created a stable, well-drained planting bed that also prevented the entire structure from becoming waterlogged and heavy. Think of it as building a multi-layered filtration system the size of a city, all hidden beneath a veneer of green. This intricate, invisible infrastructure is the sole reason Machu Picchu has not slid off the mountain during centuries of torrential Andean rains and powerful earthquakes. The terraces are not just farmland, they are massive, engineered buttresses, holding the mountain slope in place while simultaneously feeding the population. This represents a profound, almost symbiotic integration of architecture with hydrogeology. The builders possessed an intimate, granular understanding of their environment, predicting how water would flow through the soil, how weight would distribute across a slope, and how to use the land's own materials to create permanent stability. How did they develop such an advanced scientific understanding without modern tools? It was born from generations of meticulous observation and lived experience in one of the most dynamic landscapes on Earth. They learned to read the mountain's language, to see the patterns of erosion and slippage, and they designed not against nature, but in concert with its rules. This hidden foundation forces us to see Machu Picchu not as a collection of buildings, but as a single, living organism of stone and earth, engineered for eternity. And if our scanning technology can reveal the hidden foundations of a known city, what happens when we turn that same gaze upon a blank space on the map where legend says a city should be, but the jungle shows nothing at all? The hidden foundations of Machu Picchu reveal a city engineered in harmony with its mountain. But what happens when an entire civilization disappears beneath a living, breathing blanket of green? For over a century, the Maya of Central America were understood through their towering stone pyramids poking above the jungle canopy. Sites like Tikal and Calakmul seen as isolated city-states separated by vast, impenetrable wilderness. This was the story until a flight over the Guatemalan rainforest armed with a revolutionary scanner changed everything. Airborne LiDAR technology performed a swift digital deforestation, stripping away the dense canopy with billions of laser pulses to map the true ground beneath. What appeared was not a handful of lost temples, but a complete, sprawling megalopolis. The scans revealed the ghostly outlines of over 60,000 previously unknown structures, a hidden urban network of epic scale. This was not a collection of isolated cities, it was a continuous, engineered landscape. The LiDAR maps show a vast web of raised stone highways called Sacsayhuamán, connecting settlements across miles of rugged terrain. They reveal complex irrigation canals and terracing that turned steep hillsides into productive farmland, and they show formidable fortifications and watchtowers, hinting at a society that managed both abundance and conflict. The scale of landscape modification is breathtaking, a complete reworking of the tropical environment to support a population that archaeologists now estimate was in the millions, far greater than anyone had dared to propose. This discovery shatters the old narrative of mysterious, empty ceremonial centers. It paints a picture of a civilization with staggering engineering prowess and logistical organization, one that managed a delicate ecosystem for centuries through sophisticated hydrology and agriculture. They built not just monuments but an entire infrastructure for living. This revelation forces two profound and haunting questions. First, how did such a populous, interconnected society sustain itself so successfully in a challenging environment? The answer is written in those laser-mapped canals and terraces, a testament to sustainable, large-scale environmental engineering that modern societies could learn from. And second, what complex cascade of factors ultimately led to the abandonment of these meticulously engineered landscapes? While no single cause provides a simple answer, research points to a combination of prolonged drought straining their water systems, environmental degradation from centuries of intensive farming, and social upheaval likely exacerbated by these pressures. Their greatest achievements in managing the jungle may have, over time, reached a tipping point. This lost megalopolis stands as a powerful reminder of both the heights of human ingenuity and the fragility of even the most brilliant systems when faced with a changing world. From these vanished jungle cities, our search for ancient secrets now leaves the solid ground of continents behind, turning to the restless sea, where even greater engineering mysteries lie submerged beneath the waves, waiting for their stories to surface. A single ship, resting in darkness for over 3,000 years, holds a map of the ancient world. The Uluburun shipwreck, discovered off the coast of Turkey, is not merely a collection of artifacts on the seafloor. It is a perfectly preserved moment in time, a Bronze Age merchant vessel caught on its journey from plenty to somewhere else. Through the meticulous process of underwater photogrammetry, where thousands of overlapping photographs are stitched together into a precise three-dimensional model, archaeologists have done something extraordinary. They have virtually raised the wreck, not by moving a single artifact, but by reconstructing its final, settled state on the seabed. This digital resurrection reveals a secret far greater than the value of its cargo. It reveals the mind of its captain. The model shows a hold organized with the care of a master strategist. Heavy copper ingots, shaped like ox hides for easy carrying, were stacked in neat, interlocking rows along the keel to act as ballast, stabilizing the ship against the roll of the waves. The equally vital but chemically reactive tin was stored separately, likely to prevent the two metals from fusing during a long, wet voyage, a basic but crucial understanding of materials. Fragile cobalt blue glass ingots from Mesopotamia were nestled securely, while precious ebony logs from Africa were trimmed and positioned to maximize space. Every amphora of resin, every piece of jewelry, every container of precious spices had a designated place, a calculated position based on weight, fragility, and accessibility. This was not a haphazard pile of treasure, it was a loaded blueprint. It demonstrates a sophisticated, perhaps even standardized, knowledge of naval architecture and stowage logistics. The builders of this vessel and the merchants who loaded it understood hydrostatics, how the distribution of weight affects a ship's stability and seaworthiness on open water. They planned for a journey of months, not days, accounting for the consumption of supplies and the shifting balance as cargo was potentially traded along the way. This single ship becomes a floating archive of global connection. Its cargo list is a catalogue of the late Bronze Age, with raw materials and finished goods from at least 7 different cultures spanning from the Baltic to Nubia. It carried the very ingredients of civilization, copper and tin to make bronze for tools and weapons, glass for luxury ornaments, exotic woods and resins for the elite. This vessel was a thread in a vast, intercontinental web of trade and diplomacy, likely serving palaces and empires, facilitating not just commerce but the exchange of ideas, technologies, and artistic styles. What trade agreements or royal gifts did this cargo represent? What stories of distant lands did its crew carry? Its careful loading speaks of a world already deeply interconnected, where the safe passage of a single ship across the Mediterranean could influence the fortunes of kingdoms. This mastery of the sea, of balance and logistics, finds a startling parallel on land, in a place where another ancient culture mastered a completely different kind of movement, one that defies simple explanation to this day. The careful loading of the Uluburan ship speaks of a mastery of balance on the open sea, but on a remote island in the vast Pacific, another ancient culture mastered a different kind of balance on land, moving mountains of stone with what appears to be a gentle, rhythmic sway. The Moai of Rapa Nui, with their solemn, towering gaze, have long been symbols of a profound mystery. How did a people with no metal, no wheels, and no large animals move these colossal statues, some weighing over 80 tons, from the quarry at Rono Raraku to ceremonial platforms called Ahu scattered kilometers away across rough, hilly terrain? For years, theories ranged from divine intervention to elaborate systems of log rollers. But the island itself held the answer, etched not in the statues but in the ground beneath them. Recent LiDAR surveys, which can map the subtle contours of the land beneath vegetation, have revealed a hidden network of prepared roads radiating from the quarry like spokes from a hub. These were not mere footpaths. The scans show engineered roadways with raised beds, carved curbstones, and carefully graded surfaces, all leading directly to the Ahu sites. This discovery is a game changer. It provides the physical evidence for a transportation method once thought improbable, that the Moai were not dragged horizontally, but were walked upright to their final positions. Experimental archaeology has proven this method works. By using strong ropes to rock a statue forward in a controlled, side-to-side motion, small teams can pivot the massive figure along a prepared path, making it appear to walk with a slow, dignified gait. The prepared roads, with their gentle slopes and cleared paths, were essential infrastructure for this delicate operation. Creating this network was itself a monumental feat of communal engineering. It required surveying the island's topography, planning optimal routes that avoided impossible obstacles, and then mobilizing a workforce to carve curbs, level surfaces, and maintain the roads. This speaks to a society with a high degree of social organization and shared purpose. What level of coordination, communication, and collective will was necessary to orchestrate the movement of hundreds of these giants across the landscape? It suggests a culture unified by a powerful spiritual or social vision, one where the entire community invested its labor in a project that connected their sacred quarry to the coastal realms of their ancestors. The roads are a testament not to a people who collapsed from ecological folly, but to a people who achieved something astonishing through cooperation and ingenious practical physics. They moved their gods by convincing stone to dance. This ancient understanding of how to work with natural forces, of using rhythm and leverage to achieve the seemingly impossible, finds a brilliant parallel in a much drier climate, where another civilization learned not to move mountains, but to make the very air give up its life-giving treasure. While the Rapa Nui roads guided walking giants, in the scorching deserts of Iran, ancient engineers mastered a more elusive element, the wind itself. Their solution stands as elegant silhouettes against the sky, the tall, chimney-like towers known as badgers or wind catchers. To the untrained eye, they are beautiful architectural ornaments, but thermal imaging and advanced computational fluid dynamics simulations have revealed them to be masterpieces of passive climatic engineering. These scans show the invisible ballet of air within the structures. The badger is designed with openings facing the prevailing wind. As even a faint breeze enters, it is captured and funneled down a vertical shaft, descending into the heart of the building below. Simultaneously, the sun-heated air inside the structure, being less dense, rises and escapes through other openings in the tower, creating a continuous, self-sustaining circulation. It is a natural air conditioning system powered solely by physics and precise design. The sophistication deepens further. Some of these wind catchers were ingeniously connected to the underground water channels known as kanats. As the dry desert air flowed over the cool, damp surface of the kanat tunnel, it would pick up moisture and drop in temperature even more dramatically before being delivered into living spaces. This created a refreshing, humidified breeze in the middle of an arid landscape, a miracle of comfort engineered from stone, wind, and water. This technology was not invented overnight. It represents a sublime form of knowledge refined over countless generations, a deep, intuitive understanding of local microclimates, airflow patterns, and material properties. It required no fossil fuels, no moving parts beyond the air itself, and it provided sustainable comfort for centuries. This ancient intelligence poses a vital question for our modern world, grappling with energy-intensive cooling. How can these timeless principles of passive design, of working with nature rather than against it, inform the sustainable architecture of our future? The answer lies in looking back to this elegant fusion of form and function, where buildings breathed with the desert, offering a blueprint for resilience written in brick and breeze. From this mastery of earthly climate, our exploration now ascends to a place where ancient builders sought to do something even more profound, to capture and codify the very movement of the cosmos in a single, monumental instrument. The Caracol Tower at Chichen Itza is a stone eye gazing into the heavens. This unique circular structure, unlike any other Maya building, has long been called an observatory. But only with the precise eye of three-dimensional laser scanning have we truly understood how its architects engineered vision. The scans meticulously mapped every surviving window and narrow slot in the tower's upper chamber, calculating their exact angles with a precision impossible for the naked eye. The data confirms a breathtaking alignment. Specific slots are perfectly framed to capture the most extreme northern and southern points on the horizon where Venus, the brilliant morning and evening star, would set during its complex 8-year cycle. Another window aligns with the precise location of the summer solstice sunset. These were not decorative openings. They were calibrated instruments built into the very fabric of the tower, turning stone and mortar into a permanent astronomical record. The circular form itself was likely part of the design, allowing observers to move around the interior and use different sightlines for different celestial events throughout the year. This was not casual stargazing, it was a rigorous architectural science. Venus held profound meaning for the Maya, associated with war and the god Kukulkan. Accurately predicting its appearances and disappearances was a matter of both spiritual power and statecraft, potentially guiding the timing of ceremonies, agricultural cycles, or even military campaigns. The Caracol's engineered windows force us to ask what other celestial rhythms, the movements of Mars or Jupiter, the cycles of the moon, were being tracked from this silent stone turntable. It represents a civilization that built its calendar into its cities, using architecture to pin the wandering lights of the sky into a fixed, predictable order. This mastery of aligning stone with starfire finds a parallel in another ancient art, the deliberate shaping of silence and resonance to orchestrate the human spirit. The silent astronomy of the Caracol Tower depended on perfect sightlines, but another ancient culture mastered a different sensory perfection, one designed not for a lone observer but for an audience of thousands. In the sun-drenched hills of Greece, the theatre of Epidaurus stands as a marvel of human audibility, where a whisper on the stage can be heard clearly in the very last row, over 100 feet away. For generations, this was attributed to the steep, natural slope of the seating and the intuition of its architects. Modern acoustic scanning, using precise impulse responses and detailed sound mapping, has decoded a far more sophisticated truth. The perfection is engineered, a product of multiple invisible calculations working in concert. The scans reveal that the precise, fan-shaped spacing of the limestone seats acts as a natural acoustic filter. Their arrangement and the material itself subtly absorb the low-frequency rumble of the crowd, the wind, and distant noise, while simultaneously reflecting the higher frequencies of the human voice upward and outward. Even the pattern of the stone slabs on the circular orchestra floor plays a role, scattering sound waves to prevent dead spots and create a uniform auditory field. This was not a happy accident of geometry, it was a deliberate sculpting of air and vibration. The ancient builders engineered the very experience of listening, ensuring that every word of a playwright's dialogue, every subtle shift in an actor's tone, would travel with pristine clarity to every citizen in attendance. This achievement forces a profound question. Without digital modeling or even a basic understanding of sound waves as we know them, how did they achieve such precision? The answer lies in a deep, empirical knowledge gained through generations of trial and observation. They were masters of practical acoustics, learning through the feedback of performance, adjusting angles and materials over decades to create a space where democracy itself could be heard. It represents a civilization that valued shared experience and clear communication as foundational civic virtues, and they built the technology to amplify it, literally from the ground up. Our next secret, however, relies on a medium far less permanent than stone, one that fades with light and hides its messages in plain sight. The same volcanic fury that preserved the caracol's precise astronomy also sealed a library of thought in a single, agonizing moment. In Herculaneum, the luxurious villa of the papyri was buried under a pyroclastic flow of superheated gas and ash from Mount Vesuvius, a catastrophic event that instantly carbonized its collection of precious scrolls. For centuries, these artifacts were little more than charred, brittle lumps, their contents considered forever lost, as unrolling them would cause them to crumble into dust. They were the ultimate locked books, their secrets fused shut by heat and time. The key to unlocking them would not be a physical tool, but a revolutionary feat of computational imaging. A technique called X-ray phase contrast tomography has achieved what was once deemed impossible. Instead of relying on traditional X-rays that look for dense materials, this method detects the subtle variations in how X-rays are slowed down or phase shifted as they pass through different materials. The genius of this application is that it can distinguish the slight, almost ghostly contrast between the carbon-based ink used by the ancient scribes and the carbonized papyrus itself. To the scanner, the ink creates a tiny topographic signature on the surface of the crushed, rolled layers. Advanced algorithms then take this three-dimensional scan and perform a digital miracle. They virtually unroll the scroll, layer by delicate layer, flattening the text onto a screen without ever touching the physical artifact. This process is an engineering marvel of the modern age, a software time machine. It has already begun to reveal letters, words, and entire passages from lost works of Greek philosophy, potentially including texts by thinkers whose voices we thought were silenced forever. The implications are staggering. This one villa could be a snapshot of an entire ancient library, a frozen moment of intellectual life. What other lost masterpieces of literature, science, or history might be recovered from these ashes? The plays of Sophocles, the histories of Livy, the complete works of Epicurus, all could be waiting in that carbonized silence. This technological resurrection forces a profound reflection. The most fragile medium of all, ink on papyrus, has been given a second life through the most advanced imaging we possess. It is a bridge of light and data spanning 2 millennia, proving that even from total destruction, knowledge can find a way to whisper again. And as we recover these whispers of thought, we are reminded that the ancient world's grandest ambitions were often expressed not in words, but in the silent, overwhelming language of stone moved across impossible distances. The stones of the trilithon at Baalbek are not merely large, they are a physical impossibility made real. 3 colossal blocks, each one longer than a modern city bus and weighing over 800 tons, form a foundation course for the Roman temple of Jupiter that defies belief. For centuries, the sheer scale of these megaliths has overshadowed a more fundamental question: how did they even get here? The answer lies not at the temple, but half a mile away in an ancient quarry, where the scars of extraction are now being read like a textbook by high-resolution drone mapping. These aerial scans have charted every groove, cut, and abandoned monolith with forensic detail, revealing a fourth, even more massive stone. Known as the Stone of the Pregnant Woman, this block was never moved. It remains in its quarry bed, a staggering 1,065 tons of limestone, a monument to ambition that even the Romans left behind. The scans of this stone and its surrounding trenches are a masterclass in ancient engineering. They show the precise step-by-step methodology. Workers first carved deep, narrow channels around the perimeter of a chosen block using simple iron chisels and hammers. Then, with extraordinary patience, they would have undercut the block from beneath, likely using wooden wedges that were soaked with water to expand and crack the stone free from the bedrock. The quarry floor is littered with the evidence, chips and fragments in a pattern that maps the entire meticulous process. But freeing the stone was only the beginning. The true puzzle is transport. How do you move a weight equivalent to 2 fully loaded jumbo jets across rugged terrain to a building site half a mile away? The drone surveys and ground scans trace what appear to be prepared pathways, routes cleared and possibly leveled for this Herculean task. The leading theory involves a symphony of simple machines orchestrated on a colossal scale. An army of laborers would have likely shifted the block onto a massive wooden sled. This sled would then have been pulled along a track of greased wooden rollers by teams of oxen and men using capstans and ropes. The process would have been agonizingly slow, a matter of inches per hour, requiring constant adjustment of the rollers from the back to the front in a continuous loop. It was a feat of logistics as much as strength, demanding flawless coordination, immense provisioning for the workforce, and a staggering tolerance for risk. A single snapped rope or a cracked roller could mean catastrophe. This achievement forces a humbling question. What does this say about the society that accomplished it? It speaks of an empire with an almost limitless capacity to organize and mobilize human labor, to apply relentless, systematic effort to a vision of absolute power. The trilithon was not just a foundation, it was a statement, an announcement in stone that Rome could command the very earth to obey. It stands as our penultimate discovery, a perfect fusion of raw ambition, artistic vision, and engineering science, all dedicated to a meaning that was meant to be eternally visible. For centuries, we have gazed upon the serene white marble of classical statues, seeing them as the pure, unadorned ideal of beauty. This vision of pristine stone, however, is a profound historical accident. Time and weather have washed away their true appearance, leaving behind a ghost of their original form. The final secret revealed by our scanning eyes is not about structure or alignment, but about color and the meticulous planning hidden beneath it. On the surfaces of Greek and Roman sculptures, technologies like multispectral imaging and reflectance transformation imaging are performing a kind of archaeological restoration of light. These methods use different wavelengths and angled lighting to detect the chemical ghosts of ancient pigments, and more remarkably, the faint, incised lines carved directly into the marble by the sculptor's hand. These are not random marks, they are the artist's underdrawings, the precise architectural blueprint for the statue itself. The scans reveal a network of geometric guidelines, circles, crosses, and proportional grids etched into the stone to map out the placement of eyes, the flow of drapery, and the perfect symmetry of a face. This was not freehand carving driven by inspiration alone. It was a calculated engineering process, a translation of a two-dimensional design into a flawless three-dimensional object using mathematical principles and measured planning. The vibrant paint that once covered these works was applied according to this hidden framework, making the statues shockingly lifelike and polychrome, not the monochromatic icons we see today. This revelation fundamentally shatters the Renaissance-born ideal of classical purity represented by white marble. It forces us to reimagine the ancient world as one of dazzling color and technical precision, where artists were also master draftsmen and engineers of form. The serene Venus de Milo likely had brightly colored hair, lips, and garments. The Parthenon frieze was a vivid narrative painted in ochres, blues, and reds. This changes everything. It means our aesthetic, built on the quiet dignity of white stone, is a misconception. Classical art was vibrant, immediate, and engineered with a rigor that balanced artistic vision with geometric certainty. Having journeyed through these 25 revelations, from hidden chambers and liquid metal rivers to lost cities and cosmic calculators, a single, unifying truth emerges. The ancient world was not a primitive prelude to our modern age. It was a parallel age of genius, a tapestry of civilizations that achieved profound sophistication through observation, innovation, and a deep dialogue with their environment. They moved mountains of stone, charted the heavens, engineered sustainable cities, and built machines of thought, all with an elegance that often leaves us humbled. These secrets, now whispered by stone and scanned into light, are not merely corrections to a historical record. They are invitations. They ask us to look at the silent monuments around us with new eyes, to question the stories we think we know, and to recognize that the drive to understand, to build, and to reach for meaning is the most enduring human signature of all. The past is not a closed book. It is a living conversation, and we have only just begun to hear its full, astonishing story. From the vibrant colors of classical statues to the silent astronomy of stone towers, one profound truth connects every discovery. These were not random acts of construction, but brilliant, localized solutions born from a deep intimacy with place. The ancient engineer did not see a barren desert. They saw an opportunity to catch the wind and pull moisture from the air. They did not see an unstable mountainside. They saw a chance to build a foundation that danced with earthquakes. Each monumental achievement, from Petra's plumbing to the walking moe, was a direct response to a specific challenge, using the materials at hand and a generational knowledge of the local environment. This practical genius was almost always wrapped in a layer of deeper meaning. The solstice light at Newgrange, the Mercury rivers of Teotihuacan, the celestial alignments of the Caracol, these were not just technical feats, they were acts of cosmic conversation. The spiritual and the scientific were inseparable, two sides of the same coin used to purchase understanding in a vast, mysterious world. Our cutting-edge scanners, from LiDAR to Muon tomography, have become something remarkable, a universal translator for this ancient language of stone and intent. They allow us to read the rough drafts in the bent pyramid, to see the stress calculations in Sacsayhuamán's joints, and to hear the engineered acoustics in a Greek theater. This technology is not giving the ancients credit they do not deserve. It is finally allowing us to understand the full extent of the credit they have always earned. It dismantles the lazy notion of extraterrestrial intervention by revealing something far more powerful: the sustained, creative, and resilient ingenuity of human beings. So what does this mean for us living in an age of silicon and steel? It is a humbling and inspiring reminder. It teaches us that sustainability is not a new idea, but a very old one, perfected in the qanats and terraces of forgotten cities. It shows us that resilience is often found not in overpowering nature, but in learning its rhythms and designing with them. Most of all, this recovered legacy invites us to look at our own world with fresh eyes. What problems are we solving with needless complexity that might have an elegant, passive solution waiting in the wisdom of the past? The silent stones have begun to speak, and their message is clear: human creativity, when paired with careful observation, is the most advanced technology of all. This recovered legacy is a powerful mirror held up to our own time. The 25 secrets we have witnessed are not isolated curiosities. They form a single, resonant story of human potential. Each scanning breakthrough peels back a layer of misconception to reveal a past that is brilliantly sophisticated, deeply interconnected, and humbling in its ingenuity. These are not just corrections to a textbook, they are profound challenges to our assumed timeline of progress. They prove that the spark of innovation has flared brightly across countless cultures and millennia, often in ways we are only now equipped to understand. The precise gears of the Antikythera mechanism rewrite the history of computation. The passive cooling of Persian wind catchers offers a masterclass in sustainable design. The seismic dance of Inca stonework provides lessons in resilience we are still learning today. This ancestral knowledge is not obsolete. It is a vast, untapped library of solutions born from a deep and intimate conversation with the natural world. They achieved the seemingly impossible not with magic, but with meticulous observation, relentless experimentation, and a creativity fueled by necessity. As our own technology continues to evolve, becoming ever more sensitive and revealing, what other chapters of this forgotten genius will we finally be able to read? The very stones beneath our feet, the foundations of our oldest cities, the sediments of lost riverbeds, all hold silent data waiting for the right key. The dialogue between our deep past and our accelerating future has never been more dynamic or more thrilling. If this journey into the mind of ancient engineers has sparked your curiosity, we would love to hear your thoughts. Which of these feats left you the most amazed? Share in the comments below. For more explorations that unravel history's greatest mysteries, please consider liking this video and subscribing to the channel. Thank you for joining this expedition into the secrets of our shared human story. Keep